Hi everyone, this is my project for the Lab 2 assignment, so let's get started. This lab introduces the motion of a falling object. So for the introduction, the purpose of this lab was to examine Newton's second law. We let an object fall from a resting position downwards, capturing the position versus time graph. We captured the graph without the drag force as well with the drag force. The conclusion was that in the first scenario, without the drag force, that the object will move with a constant acceleration since the only force acting on it is gravity. For the second scenario, with the drag force, the object will move with constant speed since the F net is now equal to 0 based on Newton's first law. So the fundamental principles, F net equals to ma, and then is the velocity at the end equals to the velocity at the start plus a delta t. This is the update formula for the position. And here is the F drag, which is B, which is the constant of F drag, times the magnitude of velocity in square. So for the initial conditions, we said that the object is at rest at some height. We let the object fall. We consider the initial velocity to be equal to 0. Here is my tracker model. So the analysis and observations have set my y-axis plus y-axis to be upwards. Therefore, the motion of the object follows the negative direction. That's why the values of y of m decreases as t of s increases. The line of y of m, ts gravity exponential since the object is moving at a constant acceleration. Now, possible sources of error. We will conducting experiments like this, we must take into consideration the resistance. In our case, we consider it to be the drag force. This is my glow script code without the drag. This is the graph for the glow script without the drag. This is my glow script code with the drag, and the graph with the drag force. The model prediction, some similarities was that the results are consistent with physics laws. Both data and model prediction are consistent with fundamental physics principles. The patterns and trends, they follow similar patterns and trends. The only difference was that when we have the drag force, the acceleration is getting slowly reduced. So for the calculations, I have set my initial velocity to be minus 0.45 since I have started the recording after I had let the ball fall. I also used the update formula for both the velocity as well for the position. I found the average velocity by subtracting the final value with the initial value of position and then dividing by the difference of the respective time. So the coding with and drag force have used the same initial velocity as in the previous scenario. In this one, I have calculated also the drag force and the weight force, which is the force of gravity. And then I have just did the calculation to find F net. So the results, we can observe that the outcomes of both models match. You can see that both exponentials pointing downwards. Therefore, the results verify the concept of Newton's second law. So now what if the terminal velocity will be the same since after the object is thrown, the only force acting on the object will be gravity. Once gravity is the only force acting on the object, after some time t, it will get equal to the magnitude of the drag force. Therefore, we will have F net equals to 0 and the terminal velocity will be the same. Another question, critical question is, what does it mean? The velocity versus time graph without the drag force is linear, whereas the graph with the drag force has a slight curve. That happens because as the velocity increases, the drag force also increases, which leads to a decrease in the net acceleration. In addition, the terminal velocity is predicted from the drag force model. As I have mentioned earlier, the velocity increases, then the drag force increases. Because they're proportional, the weight force, which is constant, at some point will get equal to the drag force. At that point, the velocity will be constant based on Newton's first law. Thanks for your attention and for your time.